Hello, this is mathjazz from Almost Cool. This is the third video in our series of videos on derivatives. Our topic today, the product rule. This is the product rule. The derivative of f times g is equal to f prime times g plus g prime times f. While it would be nice if the derivative of f times g were f prime times g prime, it is not true. The problem that happens is when you plug fg into the definition of derivative, the fraction that you get does not factor into the limit as h goes to 0 of f of x plus h minus f of x over h times the limit as h goes to 0 of g of x plus h minus g of x over h. Since we don't factor that way, we can't get the fake derivative rule that I have written. F times g, the derivative of that is equal to f prime g prime. So we will now prove the correct product rule. We plug f times g into the definition of derivative. We get this fraction. The derivative of f times g equals the limit as h goes to 0 of f of x plus h times g of x plus h minus f times g over h. We introduce two new terms to the top of the fraction. They are negative f of x times g of x plus h and positive f of x times g of x plus h. These two things are equal and have opposite signs, so they cancel each other. We're just adding 0 to something, or that is, we're adding 0 to the definition of derivative. We don't change it. This line is equal to the previous. But adding these two terms that add to 0 allow us to break the fraction into two pieces and factor like so. We take f of x plus h times g of x plus h minus f of x times g of x plus h into one side of the fraction and split the fraction, and we have f of x times g of x plus h minus f of x times g of x on the other side. Once we have these, on the left fraction, we're going to factor out g of x plus h, and then we're going to split into two limits. We know that g is continuous because g is differentiable, so that means that the limit as h goes to 0 of g of x plus h equals g of x. On the right-hand side, we're going to factor out the f of x, which is a constant relative to h, so it can pull straight out of the limit. This is what we get after we do those steps. The limit as h goes to 0 of g of x plus h times the limit as h goes to 0 of f of x plus h minus f of x over h plus f of x times the limit as h goes to 0 of g of x plus h minus g of x over h. And we notice that the first limit, the furthest left limit on this expression, is g of x because g is continuous, since g is differentiable. The second limit is the definition of the derivative of f of x, and the third limit is the definition of the derivative of g of x. So we make those substitutions, and we end up with the right-hand side of the product rule, which is f prime of x times g of x plus g prime of x times f of x. And this proves the theorem. Thank you for watching this video. My email is mathjazz9@gmail.com. Feel free to email me for questions, comments, suggestions, corrections, or concerns about possible errors in the videos. I hope that you're enjoying learning calculus. I am enjoying making these videos, and I hope that you have a great day. Goodbye.